So how do you put these kind of systems together? And I have a business, I want to know what to do. And so there really isn't a standard right now, but the methodology that's sort of become the informal standard is called CRISP. Um, and the process of CRISP is that you go through first understanding what it is that your business wants to do. What are you actually trying to look for? In certain cases, it just might be profitability, but it also could be, I want to figure out where I can get dominant market position, where I should position, and all these issues that we've been talking about through this course. The next phase is understanding it, preparing it, modeling it, evaluating it, meaning you have to do a sanity check. And that's the thing. I used to work with these guys who were modelers, and then they would model my physical systems and say, well, it's this. I said, no, that's not what I'm saying. Well, it has to be. The model says so. It's like, you guys don't deal with reality. But anyway, whatever you do, always do a sanity check. Anytime I come to the end of something, I take a step back and say, okay, does this make sense? Can I make a story out of this that does make sense of what's actually going on? And so in detail, when I talked about all those steps before, here they are. These are the things that people look for. And this goes through the entire thing from first understanding your business, understanding going all the way to how you go about deploying it. And essentially in terms of analytics, these are all the tools that people use. And some of the more interesting ones are you can do similarity matching, meaning there's recommendations of what customers look like other customers. Link prediction, very big on networks. And that's that based on the activity of a bunch of nodes, they look at the probability that these are going to link to other things. In effect, this goes back to the Q of the Bass model. In terms of clusters, there are different kinds of clusters that come out of analytics, meaning some of them might be behavior-based, some might be product-based. You can have clusters based on any driving data or attribute that you can think of. A/B testing. Okay, it's also called multivariate testing. This has become the de facto standard for validating a model. Or I've got a couple of different paths I could go. Which one should I pick? And so, for example, I want to get data and I need responses. So do I use email or do I use mobile? Which channel works better? And so my audience is teachers and students. And when I look at the response rate, what it comes down to is that mobile overall does much better than email. By 8% to 5%. Now, is this really the right way to do it? And what A/B testing does is that when you do this, you can do actually the analytics of the system. And so what you find out is that teachers prefer emails and students prefer mobile texting. And so instead of using one channel, if I split the channels, what happens is instead of only getting 8% response, my response goes up to 11%. And those are the types of things that A/B testing can do for you. And actually A/B testing, it's all automated. That's why I haven't shown you any math. When you use these systems, whether it's Google Analytics or whatever, it's already built in there. But now you understand what it's about. So we've talked a lot about attributes, the things that drive things. These are the different kind of models they look at, meaning objective functions are basically the weights of your attributes. Loss function means how much error there is. You're concerned about overfitting. And that's how you start taking random occurrences as being fitted data. And you want to balance your field. And so here's an example of how they go about this model evaluation when you build a model. And that's that you look at, is the data real or do I have false positives or false negatives? And then I normalize it. I figure out, because I have a lot of data, what have I done? I can look at that distribution of data. And I've created a probability distribution function. And from that I can figure out what my cost benefit is. In terms of how data's been progressing, Big Data 1.0 was just about capability. How do I improve efficiency of what I already do with more data? Big Data 2.0 is focusing on interactions, and this is about social media and networks. Essentially, they're looking at the segments between nodes and seeing how they interact. So in terms of traditional analytics, originally they did stats. Now it's about big data. And the next big push right now, analytics 3.0. Thinking about Star Wars. I don't think I'm going to go watch the 8th movie. I was so pissed off at the 7th movie because it was just, I don't know, so badly done. I was just really unhappy when they picked J.J. Abrams, and forget it, this is a whole nother lecture. Anyway, so in terms of personal use, Dr. Cho has actually used data analytics in his own life. For example, I was in a football pool, and we had 26 people, and we picked against the spread. Now the thing is, what is your goal? Your goal with the spread is that everybody's going to be normalized to 50%. So all of us are basically just flipping coins every week. And what Dr. Cho did is he put together, and this is how economists think. And economists think is, what is the basic of this system? This goes into when I was talking about the nature of things. And the nature of football is, does good defense beat bad offense? I mean, does good defense beat good offense, or does... and the other thing that goes into football, besides offense and defense, is how do I play on the road versus how I play home? Those are the big discriminators. Those are the big attributes. And so all I did is I figured out the statistical averages of how teams played at home and on the road, and I did a predictive analysis of which team will win. And I did it based on the first cert suite, so there was always noise. But the thing is, that system would pick 9 games right out of 14-game weeks, and then on 16-game weeks it would pick 10 to 11 right. Now you think, well, that's not all that great, Dr. Cho. But if my expectation is 60%, and everybody else's expectation is 50%, who wins? I do. What happened is my wife went to the doctor, and he said she had cancer. And I'm like, oh, wait a minute, something's not right about this. So I actually took all my wife's records, and I started using all the data techniques I learned. And so that's the thing about doctors. Doctors were taught information, but they weren't taught problem solving. And so I started, actually using linear algebra, looking at different combinations, and looking at patterns in the data, and doing ANOVA, and trying to figure out optimal responses through Lagrangian multipliers. And then I told my wife, you don't have cancer. My wife has lupus, which is an autoimmune disease. I just said, nah, you're having a lupus attack. Look at the patterns of your tests. And they put her through a whole another month of tests, and as it turns out, I was right. So I was in an interview, and they put up a strategy, and they said which path is right. Lagrangian multipliers is basically using differentials to figure out how things are changing and to find the optimal point within a function. And so they had these 25 boxes, and I'm looking at it, and I'm thinking, okay, this is a pattern. I thought, wait a minute, these patterns have returns to them. And so I started, and there was also a hierarchy of fixed in there, and so I'm doing these calculations in my head. I could do this when I was young. And they kept saying to me, well, what do you think? I said, wait for it. He said, what do you think? Wait for it. And if I said, okay, this is a good strategy, but certain steps are out of order. And then I just started moving boxes around. As it turns out, they landed a $200 million contract from the government. And they basically complimented them about their strategy. What did Dr. Cho get pissed off? Why? Because this company was in Kansas City, and they didn't even take me out for barbecue. How rude. Anyway, there are lots of tools out there for you, whether it's Excel, linear programming, and statistical packages. And a lot of them are pretty cheap, meaning anywhere from $50 to $100 a month. And in a lot of cases, they're just free. The challenge for you is that everybody has access to the same tools. How do you gain competitive advantage? And what it comes down to is it has to be a commitment in your organization, that you're going to believe in it, that you're going to put importance on it. Because there are still laggard industries where they just sit back and say, my gut tells me this. And so here's an example of data searching, an example of data techniques, the things I try to do to find that certain words will apply to different things, and then they find the commonality. And for all intents, it's just like conjoint. Another data example is this one company figured out certain keywords, and every time these keywords would come up, the stock would go up. And so they started having search algorithms in the cloud when that was going to happen. Netflix, they look at your patterns of movies and see what it is that you like. And essentially what they do is they figure out different attribute values that these movies share in common. And they do it for a variety of systems. And so, once again, it's about, do you understand it and how to apply it? And the thing is, not everybody uses data for good things. For example, criminals are using it now to track your patterns, to figure out how to rob you. IBM used the original data system, their punch cards, to assist in the Holocaust, because the Germans understood, look, if we're going to kill 6 million people, this isn't something you do with pencil and paper. This is a lot of data that you have to put in. So there is an evil side to all this. So that's big data. You live in this age, and you can take advantage of it. There are a lot of tools out there.